Hello, I am Dr. Uksun Kim. In this video, we will be discussing the centroid of areas and composite areas. This slide shows the overview of my lecture. In the beginning, I will talk about the concept of centroid and give an example problem 1 to show how to find centroid of a basic area. Then I will provide examples of composite areas. You will learn about the steps for determining the location of the centroid of a composite area. After these slides, I will solve an example problem 2 to explain how to find the centroid of a composite area. Finally, I will provide a practice problem to check the level of your understanding related to this topic. This slide provides the concept of centroid. The centroid of an area is a point C, X bar and Y bar for two-dimensional case, defining the geometric center of an area. So this is the equation to find the X bar, and this is the equation to find the Y bar. So using the integration. If an area has an axis of symmetry, then the centroid lies on that axis. The centroids of basic shapes can be found from the following figures. This is very useful. So for the rectangular case, the both axis is the axis of symmetry. So at the center, there's a centroid. That one is the easy one. And then triangular area, there's a 1/3 and 2/3 rule. So there's a 1/3h. That one is that the centroid for this triangle. And then this one is that the semicircular area. And then the x location is that the 0 in this one, right? And then but in the y value is at the 4r divided by 3 pi. R means that the radius of this semicircle. And then quarter circle area part of that, the x-axis is at the x bar is at the 4r over 3 pi, and then y bar is at the 4r over 3 pi. And then triangular area part of that is a little bit better idea. You understand the location of centroid. So that one is at the x-axis and y-axis. For example, you have a triangle like this, and then this one is that the B, and then this one is that the H, okay? And then there's a centroid location. So your centroid location, X bar, is that the longest line of the triangle, and then from there's 1/3. That means that the B over 3. And then for the Y bar value, there's a longest line side for this one triangle. So there's a H over 3, okay? So this is the triangle shape of the centroid location. So this is example number 1. So we need to find the centroid of a triangular area, especially Y bar values. So formulate the dA for this small rectangular shape of this one, and then formulate the Y bar, and then find the Y bar centroid location. And then this one, actually the Y bar is at the integration of the Y wave. That one is at the centroid of this rectangular shape, right? And then A, and then integration dA, but range is at from the 0 to H. So this strip actually from the 0 to H, and then that is at the integration, and then you can find the Y bar value. And then next one shows the solution of the example problem number 1. So in the problem set, actually gives this equation for the linear line, but that is not difficult. You can also derive it, because this is a basic equation. The y minus y1 equals y2 minus y1 over x2 minus x1 and x minus x1. And then we just have a x1 and y1, is it the b0? So that one is the b and the 0 coordinate. And then y2, x2, y2, there's a 0, h. So that one is at this part, okay? And then we just plug in this one, x1 and y1 and x2 and y, plug in this equation, and then we can get the same equation after this one and then this one, okay? And then now, we will use the integration. So there's a little bit better way. Instead of the y equal, we need to change the x equal. So that is some kind of the manipulation. So that example, this like h or bx go this way, right? And then h, this one goes this side, minus y. And then divided by the b over h. So there's a reciprocal, and then x equals, you can get this equation, but there's a function of the y, right? And then dA, that is the area of this gray portion. So that one is the x times dy, okay? There's the area of this strip, right? And then x, we can also derive it. This is a x, it's this function. So you just plug in this one, right? So that one, instead of x, we plugged in, right? So actually this value, right? This one. And then multiply the dy, okay? So that one. And then we also find the centroid of this small rectangle, right? X wave, Y wave. And then X wave, this is a rectangle, there's obvious, h over 2. And then Y wave, that is at the Y, because this is the center location, right? And then Y bar equals integration of the area, Y wave dA, divided by integration of A dA. So this is the integration from here to here, so 0 to h, that is the range of the integration. So there's this one. And then y wave, so y wave part of that, there's a y, right? So there's a y. And then dA, this is a dA. So b over h, h minus y, then that one. And then there's a dy. And then this integration dA, integration 0 to h, and then this one. So there's a dA, this one. You just put this one. And then this is just a polynomial integration. So that is not the difficult one. So you can have this one and this one. So by, for example, integration is at what? 1 or 2 by square. And then b over h, y square, there's a b over 3h and the y cube. And then 0 to h. So you just plug in this one, and then you will get the h over 3. So that one that we talk about the 1/3 and 2/3 rule. So location of the centroid is at the longest line. There's a 1/3. Longest of the line, and then there's a 1/3. So in this case, for the y, that one is at the entire height divided by 3. There's a location. And then for your example, we didn't do that. For the x, this distance, that one is at the b over 3. There's a longest line, okay? This slide provides the examples of composite areas. Many structural objects can be considered as composite bodies made of a series of simple shaped parts like a rectangle, triangle, circular, etc. So knowing the location of the centroid, C, of the simple shaped part, we can easily determine the location of the centroid for the complex composite body, not using the integration, just a summation of the values. So in this case, this one is the A is that the semicircle, D is that the circle, B is that the square, and then C is a triangle. This kind of structural shape, A is that the rectangle, B and E is that the triangle, C and D is that the rectangle. So we know that the location of this kind of the basic area, we can easily find the centroid of the composite areas. So this slide provides a step-by-step procedure to determine the location of centroid of a composite area. Step 1 is to divide the body into pieces that are known shapes. Step 2 is to make a table with the first column for segment number, the second column for area, the next set of the columns for the moment arms, and several columns for recording result of simple intermediate calculation. But once again, I will give this one using the example. Step 3 is to fix the coordinate axis, then fill in the table. Step 4 is the sum of the columns to get the X bar and Y bar. There's a centroid. Use a formula like this. And then I mentioned, instead of the integration, just a summation. And then you can get the X bar and Y bar value. This slide shows on example number 2. So we need to find the centroid of a composite areas. So example problem, the first step is to divide it into segment, fill in the table, so this table, and then find the centroid X bar and Y bar. So in this one, you can actually make 3 segments, 1, 2, 3. So in the table, you also write down the 1, 2, 3. And then just find the area of each segment. So 1 is at the very simple. So that one is at the what? 1/2, because this is a triangle. And then 3 times 3. So there's a 4.5, right? And then number 2, that's easy because this is a rectangle. So there's a 2 times 3, that is a 6. And then 3 is at the square. So that is at the 1 times 1. There's a 1, right? And then we need to find the wave values, wave x, this one, right? So for this one, for the 1, is that because of, be careful, this is a x-axis, this is a y-axis. There's a 0 for the x value, right? So x wave in this case, there's a 1/3 and 2/3 rule. So there's a 1/3 of the 3 feet, right? That one is at the 1 feet. And then the segment 2 is at the rectangle, and then that one is at centroid, is in the middle. So this location, but that is at the negative direction. So that one is at the -1 inches, 1 feet, sorry. And then after that, the part 3 is at the 2 plus half of that. So that one is at the also negative 2.5. So don't forget negative, okay? 2.5. And then Y wave part of that is that the centroid of the segment 1. That one is at also 1/3 and 2/3 rule. So same thing, 1/3 and then 3. That is the 1 also, right? And then the rectangle part of that, there's a 1.5 feet, right? In the middle, right? And then Y wave value for the 3, there's a 0.5. So you fill out this one, almost done, because in this one, it's just a multiplication of the X wave and A, Y wave and A. So for example, this one, X wave times A, 4.5 times 4, 1, right? So there's a 4.5, right? And then this one is at the -1 times 6, -6. -2.5 times 1, -2.5. Okay, so that is the value. And then the same thing, 1 times 4.5, 4.5. And then 1.5 times 6, there's a 9. And then 0.5 times 1, there's a 0.5. So you add up all these things in this one is at the 11.5. And then, okay, 11.5. And then we need this summation also. That is at the -4, right? And then that one is at the 14. So now, based on this one, X bar value, and then -4 divided by 11.5. Okay, so there's a minus 348 feet. So that is your answer. You should put the minus, right? The Y bar value, that one is at the 14 divided by 11.5. So that one is at the 1.217 feet. So that is the Y bar value, right? And this slide shows the practice problem. This problem is asked to determine the centroid of the plate area shown in this figure. To solve this problem, you need to divide into segments in the A, B, C, D. There's maybe 1, 2, 3, 4, right? Fill in the table and find the centroid. I hope this video is helpful for you. Thank you.